I hope you and your family are doing well. Dear friends, in the previous lecture, we discussed about what is quantum mechanics. There we discussed about the history and the birth of quantum mechanics. And we came to know there that the phenomena of light gave the birth to the quantum mechanics. So today we will discuss about the nature of light. What is light? What is light made up of? Dear friends, in ancient time, many Greek philosophers were considering light as fire which emerged from our eyes. But this was not true. Indian mathematician, astronomer Aryabhat first told that light does not emit from our eyes, but it is emitted from some other source, and when it falls on any object, then we see that object. But he was also not knowing what light is made of. Newton described light as a collection of tiny particles. According to him, a light source emits tiny corpuscles of light, and these corpuscles travel in straight lines when not acted upon by external forces. Formation of shadows behind obstacles was the strongest evidence of the particle nature of light. He explained the laws of reflection of light on the basis of elastic collisions of the particles of light with the surface it is incident upon. Similarly, the laws of refraction of light were explained by assuming that the particles of denser medium strongly attract the particles of light, causing a bending at surface. But many phenomena of light like interference, diffraction and polarization could not be explained by the particles' nature of light. After that, it was Dutch physicist Christian Huygens proposed wave theory of light. According to this theory, light is a wave just like a sound. This theory was able to explain all the phenomena of light at that time. Although many physicists, especially followers of Newton, opposed this theory, they said if light is wave, then it requires medium to propagate from one place to another, just like sound. They asked that if light is wave, then how light from the sun reaches to the earth, where there is a large empty space between the earth and the sun. Then Huygens proposed the concept of ether particles, which is present everywhere in the universe. But, dear friends, from Michelson-Morley experiments, the concept of ether particles was proved wrong. Then, Scottish physicist James Clerk Maxwell, on the basis of known laws of electromagnetism, arrived at a wave equation in which the speed of this wave was equal to the speed of light. Thus, he proclaimed that light is an electromagnetic wave in which electric and magnetic fields vibrate perpendicular to each other and both perpendicular to the direction of propagation. So the wave character remained, but transverse wave. This electromagnetic wave requires no medium to propagate from one place to another, as it is a vibration of fields. So, light is a non-mechanical wave. But later, German physicist Max Planck proposed a quantum theory of radiation, according to which exchange of energy between radiation and matter takes place in the form of packets of energy. This packet of energy is called quantum, and quantum of light is called photon. The energy of one quantum is h nu, as we have already discussed in the previous lecture, where nu is the frequency of radiation and h is the Planck's constant. This quantum also behaves like a particle. Einstein, on the basis of this theory, explained the photoelectric effect. De Broglie combined two equations of energy, E is equal to h nu and E is equal to mc square, and concluded that a wave has also particle nature and a moving particle has also wave nature, called as matter wave, and he found formula of wavelength associated with the wave nature of a moving material particle, that is lambda is equal to h by mv, where lambda is the wavelength of the wave nature of moving particle, h is Planck's constant, m is mass of the moving particle, v is the velocity of that particle. So light has dual nature called wave particle duality. Similarly, a moving particle has also wave character and known as matter wave. So, dear friends, I hope you have understand what light is. So, from this discussion, we have come across the conclusion that light is not only particle, but light is particle as well as wave, and light has both character. When light is traveling in the vacuum space, it is in wave form, it travels in wave form, and when light interact with matter, it shows its particle character, and this is the mystery of light which revealed. So light is wave as well as particle. Light has dual nature. Thank you friends. I hope you have understand about the character of light. In the next lecture we'll come across with some other topics. Thank you for giving your valuable time to watch the video, and I request please like, subscribe and share the channel so that you will get a further notification